I've had a couple of folks request that I do an explainer for these weird little robots. So let's do it. They're pretty simple, really. It's a 4-bar linkage with a hobby servo to make it go. Then at the tip, I put different kinds of sensors so that I can see what that kind of sensor feels like, what it's like to interact with that kind of sensor, and how it makes the robot behave. I don't really think you can use a sensor in a robotic context until you can experience it in a visceral way and understand how it responds to different kinds of interaction. Otherwise, everything else just gets more confusing. So here I've got a touch sensor. Here I've got one of these pretty typical ultrasonic rangefinders that you get in robotics kits. They're super cheap, right? Everywhere. These are good for longer distances. Actually, they're not as good at these short distances. They're not as accurate. They're more noisy. Here I've got this kind of same thing, but with an infrared rangefinder. And this only has a max distance of 30 millimeters, I think, or something. 3 centimeters. It's really good at close distances and very, very responsive. Really fast. Each of these robots are the same. Like I said, it's a 4-bar linkage and a servo motor with a sensor on the end. So let me start by talking about the mechanical part here, the 4-bar linkage. Here we've got your basic 4-bar linkage. 1, 2, 3, 4 bars. They're connected here so they can pivot. And you can see that when you keep these lengths the same and these lengths the same, then it will give you essentially kind of a parallel action. It does have kind of an arc to it. But if you put the sensor here, then at least you get more or less thrust motion. We also have another version of the same thing, not used here in these robots, but worth mentioning. If you take the same 4-bar linkage and you flip it, so you cross two of the members, then you get a quite different behavior. When you go to push it, instead of moving parallel, this top bar pitches over and exaggerates the motion. So this is the kind of mechanism you would want for something more like a finger or another kind of biological kind of reaching or curling motion. So now that you can see that this is just a simple 4-bar linkage, let's talk about the rest of the build. Like I said, I've got a sensor mounted on the end here. In this case, our little ultrasonic rangefinder. Then the wires go back here into our little circuit board. Our servo motor also has its own wire. And then power, to plug this thing in, it has a wire going back to the circuit board. Let's take a look at that board. This little white brick here with all the holes, we call this a breadboard. That's what I'm also calling my circuit board. It's where you need to be able to lay out your different kinds of wiring. Our servo motor gets plugged in here. Our sensor comes up and gets plugged in. We got power coming in and is plugged in. This is an Arduino Nano. This is our microcontroller. And this is the brain of the robot. This controls everything. Right behind the Arduino, we've got this little tiny green board. This is a voltage regulator, also known as a buck converter. This steps the voltage down for the servo motor, but it also makes sure that it has its own power supply and isolates. And if you don't do things like this, when you're using electrically noisy components like motors, you'll get bad side effects, behavior you don't understand, or the board will just reset because it will be drawing too much power. The motor will draw too much power from the board. We've got jumper wires coming over to connect with the sensor coming in. We've also got a jumper wire coming over to connect to the servo and control that. And then I've also got some little black and red wires that are super short. I use solid core wire. I bend it into kind of a staple shape and shove it in so that I don't have so many jumpers sticking up. These get kind of hairy here. And then I've also got a power switch over here on the side to turn the robot on and off. The fluid and robust behavior in this robot is made possible by a software framework running on this Arduino Nano. The framework's called Powder of Life, and it connects these different components together and creates this robust, naturalistic behavior. It's open source, and there'll be a link in the description. But you can fire up that code on an Arduino board and do a similar kind of build and expect roughly the same behavior. This is the GitHub page for Powder of Life. When you come to the GitHub page, you can see that there's a README and a basic description of where the name and project kind of got started, as well as some early examples that were proofs of concept. But for our purposes today, we're just going to go into the Arduino folder and grab powderoflife.zip. This is the Arduino library that we need to install. Open up the Arduino IDE, go to the Sketch menu, go to Include Library, and say Add Zip Library. Navigate to your powderoflife.zip file, and that should install the library. Once you've installed the library, you should be able to go to the File menu, Examples, scroll to the bottom, and find Powder of Life. Starting out has some simple things, so you can get familiar with how the framework functions. But today I want to look at simple networks, ping sensor driving servo. This example is what drives the little robot using the ultrasonic distance finder that I showed. In the code here, you can see there's a brief description at the top. And then there are some things that need to be created to get the thing working. All Powder of Life scripts include an engine, which runs the framework and creates the parallel behavior. Next, we've got 4 neurons. There's also a timer, just to provide some debug functionality. The setup section is quite large, and this is where you establish most of the important things for using Powder of Life. We've got our debug timer, set at 10 frames a second. We have a section for our ultrasonic distance sensor, including the digital pins it's connected to, D2 and D3. We have the steering node. We have the lerp node. And we have the servo, which is connected to digital pin 5. In the loop, you can see where Powder of Life is quite different from other Arduino sketches you may have looked at. This one line of code is really all that's required. This runs the engine and provides all of the functionality that's been established above in the settings. This block here is for debugging, and you can see it's running the debug timer. That will spit out into the serial monitor so you can see what's going on inside the robot as it works. Well, hopefully that helps explain a little bit more about how these are built. What am I trying to say? Nobody will ever find out. And please feel free to post questions in the comments if you have them, and I will bother to make more videos with better explanations as questions come in. Because I don't have to post anything. Bye.